Today we're going to simplify radicals without variables. We know how to simplify the square root of 64. It's just 8. And the square root of 36, it's just 6. And the square root of 144 is just 12. And what about the square root of 68? Well, the square root of 68 is not a perfect square, so we can't just put it into our calculator and be done with it. So, for perfect squares, you'll need to know perfect squares up to 144 for my class. Perfect squares are numbers that are products of two of the same number. Like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So you need to know these: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. These are the perfect squares up to 12 times 12. So back to our square root of 68. In order to simplify radicals that do not have a perfect square, take these steps. Find the largest perfect square that divides the number. Write the factors and put a square around the perfect square. Write the square root of the number in the square outside of the radical, and then put the number left over inside the radical. Check to see if there is another perfect square that can come out of the radical. If there is, you need to repeat the process. So here's an example. We have the square root of 68. Find the largest perfect square that divides the number. And write the factors, putting a square around the perfect square. So we've got 4 times 17, because 4 is the largest perfect square that divides 68. We put a square around the 4, and now we write the square root of the number in the square outside the radical. So the square root of 4 is 2, and we put the 17 on the inside. Now check to see if there's another perfect square that can come out of the radical. There's no other perfect square that can divide 17, so this one's done. So for the square root of 72, the largest perfect square that divides it, we're looking at 9 times 8. So we put a square around the 9, take the square root of that number, which is 3, and we put the 8 on the inside of the radical. Check to see if there's another perfect square that can come out of the radical. Well, if we look at this, 8 divides into 4 and 2, so we didn't find the largest perfect square in the first place, but that's okay because I can repeat the process. My perfect square is 4, so I put a square around it and take the square root of that, which is 2, and then I multiplied 2 times this 3 on the outside to get that 6, and then my 2 comes down inside the radical. There's no other perfect square that goes into 2, so this process is done. This can be done another way. If I had found the largest perfect square that went into 72 to start with, I would have gotten 36 and 2 as my factors, and my square goes around my 36. The square root of 36 is 6, and then I put my 2 on the inside of the square root, and I get the same answer. For the square root of 40, I'm looking for the largest perfect square that divides the number. This one will be 4 and 10 as my factors. I put the square around the 4, take the square root of it, and I get 2, and I put my 10 on the inside. There's no other perfect square that goes into 10, so my problem is done. Now you try. Pause the video, do these problems, and then hit play to see the answers.